Distributed or decentralized learning is when you have multiple workers, so let's say multiple GPUs that you can use to train your network. So let's say that we will run or we will train our network with many epochs. For each one of the epochs we have many batches, and then what we can do is to organize all those mini batches in such a way that uh, part of the mini batch is taken care by one of the workers, and another part of the mini batch will be taken care by another worker, and so on. So this is called distributed learning with data parallelism, because the different workers are somehow seeing different data. And then at the end, all those workers will propose different updates for the weights of the network, and we have somehow to synchronize them. So we are doing this here. So we have each one of the workers have a copy of the weights of the network. So they do a forward pass, they compute the loss, they compute the backward pass, and propose they propose an update of the weights based on the gradients. And somehow what we are doing here is averaging the gradients coming from all those workers, then update the weights accordingly. So now we have a new copy of the weights, and we distribute back this uh, copy of the weights to all the workers. That is a decentralized learning with data parallelism. So we are parallelizing at the level of data. The other possibility is to parallelize at the level of model. So at the level of model, we would have a GPU or a worker that is somehow taking care uh, a part of the model, while the other worker is taking care of the other part of the model. So the different workers specialize in different regions of the network. You can imagine that distributing, especially when you are doing the backpropagation process, somehow you have to communicate these two workers, and so that the gradients that you have to propagate back somehow are transferred from GPU 1 to GPU 0, and this can be also a little bit complicated. But normally now many libraries like TensorFlow, Keras, JAX, not Keras, Python, they propose or they already have in place these mechanisms already implemented, so that they are relatively transparent to the programmer. The programmer only has to say which are the GPUs that are available, and somehow tell how this network how which parts of the network or which parts of the batches have to go to each one of the GPUs. And also you should pay attention to the scalability of these things, because now we have to increase the communication between workers, and then sometimes we are not fully utilizing the, the GPUs available. So there might be an increase in performance when you go from 1 to 2 GPUs, but probably not that much if you go from 2 to 8. So you have to monitor how much the GPU execution time is used.